Hi everyone. Today I'm going to teach you how to solve problems that involves rate of change. When we say rate of change, it is describes how an output quantity changes relative to the change in the input quantity. The units on a rate of change are output units per input units. And to find the rate of change in a given problem, all we need to do is use this formula. The formula is, I know for some of you is familiar. This is synonymous to the slope formula. So here in our numerator, we have change of y. So that triangle there means change of y over change of x. So let me now give you examples. Number one, sometimes you will see this kind of problem. The table shows the amount of money a booster club made washing cars for a fundraiser. Question is, use the information to find the rate of change in dollars per car. Now, if you look at the table on the right side, you may see that the increase in terms of the number of cars and the amount of money is constant. So if that's the case, all you need to do is just to pick any 2 points here and use the rate of change formula or the rate or the slope formula. So let's say I will pick this 2. Okay, now remember that x is 5 and the y is 40 and 80. So the x's are 5 and 10, and both of those goes in the denominator, and the 40 and 80 will be in the numerator. So change in money over change in the number of cars. Okay, so that's 80 minus 40 over 10 minus 5, and that will be equal to 8. So that means what? So the number of dollars earned increased by $8 for every car wash. All right. Let's go to the next one. Here we still have a table, but this time it's arranged horizontally. But the way we solve this is similar to what we had a while ago. So you just need to pick any 2 points, and by just reading the problem, the question is not really specific. It's really general. Use the information to find the approximate rate of change in miles per minute. So here I might pick this and that one, and of course it's important for us to understand how to determine the output value and the input value. So here the input value is the time, which means that goes in the denominator. The output value will be the distance, so that will be in the numerator. So it will be change in distance over change in time. Okay, so this will be 580 minus 290 over 60 minus 30. That will be 290 over 30, and 29 over 3. So that is approximately 9.67 miles per minute. Okay, so this is miles, okay, per minute. All right, let's go to the next one. All right, so here we have a table again, but I think this is more specific than the previous two examples, because here, if you read the problem, we can go to the last sentence. Find the average speed of Anna for the first 6 hours. So if that's the case, so here we cannot just pick any 2 points because the question is specific. So I'm going to choose and the 6th hour point. All right. So how will you know if those are the 2 points that we will choose? Well, these are the first 6 hours of the travel time of Anna. All right. So the output value will be the miles and the input value will be the hours. So hours in the denominator or at the bottom, and then miles or the distance will be in the numerator. So this will be 292 minus 10 over 6 minus 0, which is equal to 282 over 6, and that is equal to 47 miles per hour. All right. Let's go to the next example. Here, the question is the same as the previous one, but this time we are talking about the average speed of Mart for the last 3 hours. So that means we should be looking at the last 3 hours of this table, which means this is our first point, and the next point will be, guess what? I'm going to give you 5 seconds. All right. It's going to be 4 and 190, right? From 4 to 5 is an hour, 5 to 6 is an hour, 6 to 7 is another hour. So that's for the last 3 hours. Okay, again, the numbers on top will be the miles or the distance, and the numbers at the bottom will be the hours. So this will be 350 minus 190 over 7 minus 4, which is equal to 160 over 3, and this is approximately 53.33 miles per hour. All right, let's go to the next one. Now here we have another table, but this is more abstract because here it says that we need to find the average rate of change in simplest form, if it's a fraction, of this function over the interval 2 is less than or equal to x, and x is less than or equal to 8, or x is between 2 and 8. So here, remember that 2 and 8 are the x values. So just look for those numbers from the table, and the corresponding y values or the output values will be 7 and 35. So just use the slope formula here and solve, or the rate of change formula. So this is going to be 55, which is the output value of 8, minus 7, output value of 7, of number 2 rather, over 8 minus 2. So this is 48 over 6, which is equal to 8. Right? Let's go to the next one. Or you might encounter a problem like this. This is a graph. And here, this is similar to the table. We have 3 different points here. All we need to do is to choose any 2 points, and then just use the slope formula. So here we have change in distance over change in time. The reason why I'm telling you that we just need to choose any 2 points here because this is a straight line. So if it's not a straight line, you cannot do that. And the question must be more specific. So since this is a straight line, we can pick any 2 points and we'll be able to find the rate of change. So that's 120 over 2 minus 1. So that means I picked these 2 points, and that is equal to 60 over 1, or equal to 60. So that's miles per hour. All right. Okay, so this is what I'm saying. A while ago, it's a straight line, right? Now here, it's a curve. But of course, the question here is specific. What is the average rate of change of the function on this interval? All right. So remember, -3 and 8, those are the x values. So you should be looking at those, the -3 and 8. So where's -3? It's right here. Oh, my bad. Okay, so -3 is right here. So this is -3, and the corresponding output value of that is -90. And then 8 will be here, and that is 8 and 20. So now that we have those 2 points, let's just use the rate of change formula or the slope formula. This is 20 minus -90 over, those are the output values, and 20 is the output value of 8. -90 is the output value of -3. So minus -3. All right. So this is equal to 20 is going to be plus and plus because of those 2 negative signs. Minus -90 is going to be plus. So this is 110 over minus -3 is positive. So this will be 11. So therefore, the answer here is equal to 10. All right. Let's go to I think this is the last example. And you might encounter an equation like this: x squared plus 4x minus 4. Determine the average rate of change given that interval. So the output values or the input values are -7 and 0. So all we need to do is to find the output value of each using the lesson about function notation. So we will just substitute that -7 to x, then solve. That will be the output value. substitute that 0 to x, and then solve, and that will be the output value for 0. All right, let's do that negative 7 first. So negative 7 squared plus 4 times negative 7 minus 4. This is 49 minus 28 minus 4. So this is equal to 49 minus 32, which is equal to 17. So this is 17. For the 0, this will be 0 squared plus 4 times 0 minus 4. That is 0, so therefore this is negative 4. So now that we have those 2 points, all we need to do is to use the formula to solve for the average rate of change of this problem. So this is going to be negative 4 minus 17. Negative 4 is the output value of 0, minus negative 17 is the output value of negative 7. So this is negative 21 over positive 7. This will be plus. The answer is equal to negative 3. All right. So I hope this helps you a lot. I have given you a lot of examples that involves average rate of change. Thank you for watching.